Good afternoon, and thank you for joining us today for our Additive Manufacturing for Production Tooling webinar. A few quick items. First, if you'd like to view the presentation in full screen, please go to the three dots at the top and scroll down to the full screen option. Also, if at any time during the presentation you have any questions or comments, feel free to add them to the chat and we will address those at the end of the presentation. With that, let's kick it off to Josh Colcan.
Awesome. Thank you, Emily, for the introduction there. My name is Josh Colcan. The webinar here that we are presenting today is Additive Manufacturing for Production Tooling. So without further ado, we're going to go ahead and get started. Quick background is I'm your presenter, Josh Colcan, account manager here at CamLogic. I've been with CamLogic now for about 8 years, a little bit more. So I've been lots of facilities, seen lots of industry, parts and things along those lines, continuing to grow and move up the positions here with CamLogic, and it's been an awesome ride. I do encourage anybody that wants to check out our website at camlogic.com. We've got a lot of really neat stuff on there to be able to check out. So feel free to Google that whenever you got a free minute, and we can go from there. So before you jump onto our website, I did want to do a little brief introduction of CamLogic itself and what we are. We look at ourselves as a solutions provider more than anything else. So we do lots of things. We do capture, and what we mean by that is we do scanning, reverse engineering, and things along those lines. And we also have a fully dedicated staff for engineering and design. But we also have software through Siemens PLM that we are partnered with, that we use their software to run simulations, designs, use it for RE and other things. And we also have a manufacturing sector as well, where we do additive and subtractive manufacturing and some other really neat things as well too. So if you're ever have any issues where you're having troubles with your designing, or you have an old part that needs to be reverse engineered, or you just need something manufactured, we can take care of that for you as well. We've been doing this for a long time. Again, we've got a very knowledgeable, dedicated staff that's come from all aspects of the industry. So we were very well-rounded, and we have lots of expertise that we utilize on a daily basis. Again, please check out our website and see what we can offer. I'm sure there's always a solution that we can come up with for you. We've helped out some really good clients to keep their production on track and everything moving forward. So today's agenda, what we have is, and this is a kind of a loose agenda, but we're going to go through it anyways. It's so what is a production tool? So not everybody knows exactly what a production tool means, so we're kind of going to go into a description of that as well. But the real big takeaway here is how do we use production tools? Everybody's like, hey, we can 3D print that, or we can add and manufacture this, but where do we actually use these tools, and where do they come into effect? And then we'll also touch base on why traditional manufacturing versus additive manufacturing, what the difference is, and why you might use one versus the other. So we're going to go ahead and jump into the next slide here. So I did want to just throw this kind of slide in here too, because we have helped out some very large OEMs of coming up with either assembly aids or production tooling and things like that to really keep their business on track. So we do strive to be the leader of the pack in the additive manufacturing production tool space. Again, we've had some very, very good successes in continuing to expand into other regions and other aspects of the business to further educate people on how to be able to implement these production tools into their setting. So one thing I did want to and I always like to put in a little funny slide here, but this is a hammer. There's nothing fancy about this hammer. It's not really considered a production tool. While this may be used in a production setting, or a screwdriver, this is not really what we're talking about when we are talking about production tooling. These are off-the-shelf tools, that you can go to your local hardware supplier and be able to purchase these, right off the shelf. We're talking more about like custom tools, things that really have a unique application for them. So hammer, screwdrivers, things like that. Yeah, they can be used in production, but that's not where this is focused around. So there's three types of basic tooling, and we're going to touch base on all three of these types of tooling. But for educational standpoint, just, understand that there's three types of tooling really. There's bridge tooling, there's prototype tooling, and what this webinar is really focused around is production tooling. We've got some really good applications and stuff that you'll see later on in this slide of where we've been successful and where we've seen success in the field in the real world applications. So we're going to move on to what bridge tooling is. So bridge tooling is actually a pretty simple aspect to kind of grasp your head around. And it's, the main thing is you're bridging the gap from prototype to production. So when you come up with a prototype and you've made that design and you know that it works, right? Sometimes it takes a while to actually tool up to get that into production, whether it's being machined or injection molded or whatever the process might be. We got to be able to bridge that gap to keep the production going, and that's where bridge tooling falls in. Now, again, these categories can kind of be shifted around and things like that, but bridge tooling is a really good part of the business, and this is a great use applications for additive manufacturing because they can keep those long lead times down from tool makers, and they can keep your production up and going and keep profit in your pocket because nobody wants machines that are not running, waiting on suppliers to send them parts or even raw materials. Now, with today's raw material shortages, this bridge tooling seems to be creating a larger span across the tooling industry, and these bridge tooling parts are actually becoming more of the production parts because these raw materials, suppliers, employee shortages, all things along those lines are really pushing this to become a more usable technology for these applications. So typically bridge tooling is made from aluminum machine parts, or they can also be 3D printed and everything as well here. This part on the right here is just a simple 3D printed fixture, right? But it's made for scribing or acid etching into parts for final production. This obviously would probably be machined after, for full production, but in this case, they didn't have the tools ready to be machined, so they had to be additive manufactured to make sure that it's going to be able to hold the part in place, and that the scribers were actually going to be able to dig into the metal to create those features on there without slipping. Once they proved all that out, then we can move on to the next step. So the other category that we're going to get into before we go into the production is the prototype tooling. Now, this is a great category where additive manufacturing really shines. So prototype tooling really is basically proof of concept, right? You come up with a design and you think it's going to work, but you're not really sure, right? We got to actually put these into the real world and make these things function and do what they're supposed to do without breaking or losing a part or whatever the application might be. Sometimes they're also meant for just testing for fit and function to make sure that the part is actually going to slip into whatever the application might be. Part validation also as well, to be able to make sure that these prototype parts are actually going to perform the way they want before you tool up to make your final product. Again, whether it might be mass machine production, injection molded, casted, whatever that method might be, we have to validate these parts and make sure that they're going to work before we actually ramp up for that full scale production. And that also falls into the final test for productions. And basically the biggest thing with prototype tooling is we need to find out how they're going to perform, because we can run all the simulations in the world, but we just don't know how these tools are going to perform until we actually put them in the real world and start putting them through the paces. We have some really cool slides coming up here at the tail end of the presentation that'll go through all the final testing and how we validate our parts. And find out this information that we really just don't know from some of the software simulations and things like that. Again, real world testing is the real key here. So Production tools. I mean, production tools can be many things. They can be anything from grippers, underarm tooling, stamping. There's lots of things that can be considered production tool. This isn't necessarily a cut and dry scenario, but this should be able to give you some ideas of what we're talking about when we mean production tools. So these are tools that are used in a day-to-day operation in a production setting, whether that's on an assembly line or in a machine shop or whatever that might be. These tools are going to be used as production. They're going to be able to help make your part for your production. Now, these production tools, obviously, these are meant to speed up production and increase profit margins. The less lead time you have when you're waiting for your production tools means that you're ramped up for production that much faster in making parts. The faster you can make parts, the faster you can get those out to your market, and you can increase your profit margins because you're out before everybody else. The other thing too is increase production efficiencies. And what we mean by that is sometimes design changes need to happen, right? So we might be able to tool something up and have it manufactured and find out that it doesn't work or it could be done better, right? Everything can be done better is the motto that I like to live by. Now, why we've perfected many things is there's always room for improvement. And as long as you have that mentality, you can always find new use cases for production tools using additive manufacturing. So the real world solution is to keep your product in motion. Anytime your production stalls or stops, you're losing profit. So we want to make sure that these production tools are actually going to last. And how we do that is with additive manufacturing. It has come a long way in the years of what additive manufacturing is, the processes, materials, and things along those natures. So the next thing we have here coming up is a production tool that we actually designed in-house here at CamLogic using a Markforged 3D printer. And this part was printed out of onyx and reinforced with carbon fiber. Now, this is not an overly complex part or anything. It's actually a stamping tool. And I have a video coming up here that'll actually show this in motion. And it's really cool. I actually got to sit and do this press break. It was really neat. I've never done anything like that before. So it was really cool to kind of see this whole design come from the design state to the validation to actually producing the parts. These parts, again, are meant to speed up the production setting. A lot of times these will be cut from tool steel or something like that. And if the radius is off or it's things along those lines, and these aren't being bent correctly, then we got to go back to the drawing board. We've got to redesign the tool, then we've got to recut it, and things along those, where when we additive manufacture this production tool, we know that this part is going to come out exactly the way we need it bent with the radiuses and everything that we need. And if there's any design changes that need to be made to this part, we can make those design changes, print this thing out overnight, come out in the morning and test our new iteration or our new design. Other things that we can use in a production setting for additive manufacturing is profile gauges. Now, profile gauges, we can use these for a lot. We can use these for in-process inspection. We can also use these as assembly aids or production tools. For things like this could be like a multiple pipe routing setup that might need to be welded together, or fittings or anything like that to be welded on there. And we need to make sure that everything stays straight and aligned. So when this part goes into final assembly, then we make sure that it fits and it works as intended, because last thing we want to do is make a part that doesn't work. So the other thing too is a big thing that I walk around and I see shops is tons of scrapped parts sitting in bins waiting to go back to the recyclers. So using these tools, these profile gauges, to ensure the quality of your parts is going to mean less scrapped parts. Now, less scrap parts, obviously, first thing is you're thinking your bottom line on your materials, right? But you got to remember that every scrap part that comes off of the assembly line is also downtime too. So the more scrap parts you have, that means that that machine basically ran for a negative amount of money, which we want to eliminate that, or the process. So having these fixtures and these gauges and everything can obviously limit the amount of scrap materials that are going into the recycle bin. It's going to boost up your profit and make your bottom line even better. Other things that we see the additive manufacturing for production tool usage is brackets, complex brackets. Now, I'm not talking brackets that hold up your bookshelves or something like that. You know, those are off-the-shelf components. But this picture on the right here shows a pretty complex bracket that's holding a part in place that's going to be riveted together. And it's very thin metal. So they had to find out a way to fixture this to actually hold it for their assembly process. And they tried to do, you know, machine parts and things like that. And it was very costly. It was very complex. So with some design intent going on, we this part was designed. They had the CAD and everything, so they're able to do a subtraction from basically a block of material in their CAD and design this part for additive manufacturing that clips onto the part perfectly, and they're able to assemble it with a non-marring material, and then they're simply able to just slide this piece out of that bracket, and then they put the new one in and keep production going on from there. The other nice thing, again, is these design changes, right? If this doesn't work on the first one for your production tool, or maybe your customer has a design change, well, if you tooled up for normal production, whether it would be stamping or whatever, right, and you make a design change, those are very, very costly changes. Those changes take a lot of time, they take a lot of money, and they take a lot of resources. Now, if you can prove these design changes out for your tools using additive manufacturing and essentially have your problem solved the next day, you got a lot of uptime there and very little downtime. So it's easy to justify, you know, being able to come up with additive manufacturing solutions for these types of tools. Now, again, there's not a cut and dry scenario on what a production tool is. It's really any tool that helps aid the production process. Now, there's tons and tons of processes out there in the production world. So, you know, there could be 1,000 different types of brackets or anything along those lines. So the next category we have is the tool usage. So this one I really like because this kind of digs into the real world scenarios where I've been on shops and I've seen these parts actually in production lines and how they've worked and how they've been able to speed up and aid the production process. Some of these places I go to, if their machine goes down or anything along those lines, you know, it costs thousands and thousands of dollars a minute in downtime, and we really can't have that. So we want to make sure that we do it once and we do it right. So that also brings us to kind of niche materials and things like that, but like Inconel is what we call an alloy or a super alloy, and it's very, very hard to machine. It's a work hardening material. So what that means is as we machine this, it actually hardens the steel or the metal, and it actually makes it harder to machine it. So being able to print these out using additive manufacturing is one going to, you know, be possibly more cost effective right off of the bat, but it's going to shorten your lead times. I've been to a couple machine shops that, you know, were doing like aerospace and things like that, where Inconel was being machined, and they got machinists over there snapping off bits and dulling out their bits and crashing machines because Inconel is very, very hard to machine. But this particular application, this was a high heat application where it would pick up a part, it would go through a heat cycle, and then it would place the part back down. So that's why they had to use a high temperature metal like Inconel. So being able to print these versus machining these ended up saving this company a lot of money and time to be able to develop this solution. This was a production tool. It's still being used, and it's been a great application. Again, these are endless. We have so many of these applications here at CamLogic. Encourage people to, you know, check out our website, and we can even come you can come into CamLogic, we can give a demo, we can see sample parts. We've got applications sitting on the walls with some really, really cool stuff that I would really turn on some light bulbs and get the wheels turning if you're kind of struggling to find that fit for the additive manufacturing in a production space. Another thing we found that was really cool, and I was directly part of this project. It was a very neat project. Didn't really, you know if we could do it at the beginning, but that's where the, the beauty of additive manufacturing really comes in, right? So this was a balance fixture for a company, and they came to us with a problem, right? So we didn't know the solution right when they came to us, but we knew the problem, we knew what we needed to do to fix it. We just had to figure out how we were going to actually do that. So originally, this spoked piece in the middle that's in black was machined out of aluminum, but the weight restrictions for that black piece being machined out of aluminum, it was higher than what their balancer could actually have with their part on there. So they came to CamLogic and they're like, we need this fixture. It's got to be rigid and it's got to be lighter than what the aluminum is going to come into. So our design team went to the drawing board and using the carbon fiber 3D printing and some other manufacturing techniques, we were able to create this balance fixture, come in underneath the customer's weight threshold, and it performed exactly how they needed it to perform. So this is a great application where we thought out of the box to provide this customer a tool using additive manufacturing for their production. They were not going to be able to move forward with production if they couldn't validate these parts and balance them without, buying a whole new balancer at hundreds of thousands of dollars or anything like that. So we found the solution. We printed all these in-house, assembled it, balanced the actual fixture that we had, and then we sent it out to them. They made their parts that they needed, and everything worked as intended. So this is a win for additive manufacturing. This piece right here, the picture doesn't justify it, but it's about 3 feet across. So these were all pinned together because it was larger than our printer could actually produce in one solid piece. So what we did is again, our design team split this thing up. We used dovetails and pins and some other, very unique ways of attaching these parts together, and we were successful in that aspect. So back to these stamping parts. Again, these were traditionally machined out of a tool steel, long lead times and things like that, but the design changes, and there's a lot of things that come into making tools like this. When you're thinking of like stamping applications, is you've got to worry about like spring back of the material, and that means basically when you press a piece of metal, right, and you form it into a shape, it's going to have a little bit of rebound back to it. So you essentially have to overbend it to compensate for that spring back. Sometimes the engineers can nail it right on the nose on the first shot, and other times it takes different types of tool iterations to make that happen. Again, we achieved this making 3D printed parts out of carbon fiber and onyx material. So I do have a video coming up here that has the actual tool working in action. We sat in front of a press to make over 1,000 of these metal blank parts. This was a 30-ton press bending 3mm steel parts for production. So this was a proof of concept, but it ended up working so well that we actually ended up stamping way over 1,000 parts. I don't remember the exact number, but this tool outperformed everybody's expectations. We really didn't think it was going to be able to make the large quantity of parts, right? This was going to kind of almost be as a bridge tool, but it ended up working so well that it ended up being a production tool. So everything kind of went hand in hand together on those. And here we go. We got the video in action here. As you can see, we're stamping these steel plates, and I know it goes very fast, and those are my hands. Just FYI, I did sit in front of this press for hours. It made me realize that I did not want to sit in front of a press for hours, but it was very, very cool to actually be able to do this and to, be part of something that I wasn't 100% familiar with. So it was a very, very cool learning aspect. And then just being in a machine shop, seeing all the different types of methods and things like that, again, really just opens up my eyes is how we can start implementing this additive manufacturing into some of these real world production scenarios, creating tools, fixtures, brackets, whatever it might be. Again, we're very good at spotting for these types of applications. So another thing that I wanted to go on for production tooling is the concept of lightweight tooling. Now you saw this kind of in the balance fixture portion, but we took that even farther. So again, customer came to us with a problem. They needed to lightweight a conveyor system for their production. So they had the design, everything was drawn up, and they had it, and they said, you know, they came to us and they say, we need to come up with a solution. We have these hangers that we can't make them light enough with traditionally machining these out of aluminum. So they came to us, they say, Camlogic, how can you make these better? So again, our dedicated design staff said, you know, hold on, we've got this. Let's come up with some designs. So on the left, you can see is the aluminum design of this production tool. And this was overweight. This wasn't going to work for the company. They were going to end up having to retool their whole conveyor system with larger bearings and more robust if they went with this design, which was going to cost millions of dollars and be weeks and weeks, if not months of downtime. Now, when you're talking thousands of dollars per minute of downtime, this is not acceptable, and they had to come up with a solution fast. So what we did is we came up with a solution. We drew it all out, and we came up with these carbon fiber hangers. And now these were a hybrid design. They have 3D printed parts, they have machine parts on them, and then they're all assembled again to make this part, but we had to stay underneath that weight rating. So that was great. We designed the parts, we, you know, ran our simulations and everything, but we had to make sure that we had all our loading and conditions correctly on this. So we used our software here, our Siemens software, and we started to run simulations on these parts versus for what we created in-house. So we came up with a design. We plugged all that design into the software, applied the loads and forces that were going to be put on these parts, and we ran an analysis on all those load conditions. And as you can kind of see over here, and then there's a color map, and it tells you, it kind of shows you where all the stresses and everything are going to be and how much flex you're going to have on these parts. Now, what actually happened with these parts was kind of a good thing. Is they were strong enough to perform. They did the job that they were supposed to. They performed the way exactly as intended, but they created a engineered weak link in the system. So what I mean by that is when this system crashes, because it does happen on assembly lines, whether, you know, somebody stops it for some reason or somebody left a screwdriver where it might not supposed to be, these assembly lines, they run into things and they crash. Well, if you don't have a weak link in your chain, then you essentially can destroy the whole chain or the whole process. So having these parts that were strong enough to be able to lift up the application, but having an actual engineered weak link in these made it so when they crash that there was a simple small part that could be replaced very easily and on the line within minutes. So they would replace that weak link, and then they would be able to have the production line back up and running in no time at all. So that was another great application of where that would be. So we came up, we did our load testing, we did our simulation. Again, we didn't know for sure if these were going to be able to withstand the forces. Simulation's great, and it gets you 95% of the way there, but the proof is in the pudding, really by sending these out for certified destructive testing. So here is an actual 3D printed hanger that you can see here on the right that we sent out to a certified place to actually do the load testing on this. So what they did is we gave them all the conditions, the forces that were going to be applied, the weights and everything along that, and they started to do cycle testing and durability on this. Obviously, we needed to make sure that the part is going to survive their application. So one thing that they did is they did all this testing and everything. The part passed. We were very, very happy with it. Actually, it exceeded our expectations, which is great. Our software told us that it would survive, but we needed to make sure. So they did all their testing and everything on it. And then when they were done and it passed, we were like, well, when is it going to break? Like, how much load can this actually take? Because we didn't obviously engineer it or simulate it to take it to the breaking point. We wanted to stay under that, you know, just like how they rate a rope. If a rope's rated for 100 pounds, really the breaking strength on it's about 150 pounds, but better to be safe than sorry. So on the left here is we got our graph, and that shows us when that part, you know, actually broke, and it stayed well within the range that we needed it to be. And then once we validated that, we were able to assemble, ship these off to the customers, and they're still running in production today. And we've had many applications that are very similar to this as well. So over here, this is a little slideshow here, or a little picture of 3 different types of manufacturing methods, or 3 different material choices. So there's traditional manufacturing versus additive manufacturing. So traditional manufacturing might be a casted, forged, or machine typed part, which is on the far right. And on the middle is that same concept, but it's been 3D printed. Now, the reason that it was 3D printed out of 17-4 stainless steel in the middle was, again, to that proof of concept to make sure that this tool was actually going to perform the way that it was supposed to. This was going to be a low volume tool, and these were essentially going to be casted, was the end method, but we ended up finding out that they only needed so many of these. So we found that 3D printing them was actually a more viable solution than it was to have these set up for mass production. And again, just the proof of concept here on the left that we printed out of composite materials, just to make sure that our fit and function was before we went to the next step with the metal 3D printing, because obviously composite 3D printing is less expensive than metal 3D printing. So we wanted to make sure that all our clips and everything worked and performed as expected. So one of my favorite materials to displace when using additive manufacturing is Delrin. So I'm sure if you're from this industry, you have probably heard that material name thrown around. It's used a lot in the automotive industry. It's very, very expensive when you're considering machining it compared to a lot of other plastics. So on here, and I got a additive manufacturing design of this actual part here on the next slide, and we'll kind of compare apples to apples here. But I was at a place, and this is a wire management production tool. So what this was used for was to simply, it's actually got magnets on the backside where that arch is, and they would clip this onto their product. And as this would go down the assembly line and rotate, this would keep the wires up in place before they had their actual clips and everything installed. That way they didn't have wires being hung down and tangled into everything else during production. So they had this part, was originally machined out of Delrin. It took a skilled machinist about 2.5 hours to machine one of these pieces. And the material cost was about $3.83. Not a whole bunch, right? But when you're talking and you need, 500 of these, all of a sudden that price per part, it starts getting up. And then you look at your machine hours to produce that. And then you also got to look that you need a skilled machinist to do your programming and pathing and sit there and watch this machine. So if you take those estimated wages of your machinist and the cost of the part in the machine hours, that actually ends up being about $55 to be able to make this part out of Delrin, which it really didn't need to be out of Delrin, but again, that's what they've always done. So that's what they continued to do until we started to displace these types of tools using additive manufacturing. So just look at that cost per part at $53.83 machined out of Delrin. Again, that's estimated cost of what it would cost, for machine, material, and labor. So this same part uses less material, right? So again, this is that less waste, right? So subtractive manufacturing, there's always waste associated with it. And that's another cost too, because you got this waste. Most cases that has to be recycled. So you got to pay somebody to come and pick this material up. Whereas additive manufacturing, there was almost, the way this was designed, there was almost no support material in this. So there was very little waste to do this. So it wasn't very much faster to produce these out of a additive manufacturing solution. This particular part was printed on an X3 Mark Forge carbon fiber 3D printer, and the material cost was $2.23. Again, we're not setting the world on fire with saving on the material cost. But what we are saving on is that one-time setup, right? So we do still have somebody that has to physically, load the printer with material and come up with these designs, but we call it lights out manufacturing. This particular part, they were able to put about 15 of these on a build plate and run these overnight when nobody was there. So now we can start to take that operator wage and knock that down, because that operator really just had to set these prints up, hit the print button, and continue to go about their daily routine, continuing to make parts or whatever their job might be. So the cost per one part is about $15. So we're looking at about a $40 difference per part when we start adding in our labor and everything along those lines. And there's actually a little bit of money baked into this for machine wear and tear and the purchase of the hardware itself. Now we are comparing these to large, CNC equipments that can, run anywhere from $500,000 and stuff, but all that cost has to be passed down for the parts. So another really good application that I seen that was a really cool tool. Now you guys might look at this and you go, wow, that's so simple. Why are you showing us this? Again, this was machined out of Delrin material because that's what they typically use, right? So this was machined out of that material, and it didn't really need to be. So this was again for a production setting. So this is considered a production tool. This was for an assembly line where a tailgate kept swinging open on a vehicle, and it was causing obstructions in the assembly line. So they had to come up with a temporary solution before, the final latch was installed. They machined these out of Delrin. They were very costly. They were very expensive. And really, they were way too robust for what they needed to do. They really just needed to keep a gate from hinging back and forth. So what they did is they took their concept that they made out of, they machined it, and they knew it worked, right? So they had their overall design, but they're like, man, there's still a lot of wasted material. This is way thicker. We're subtractively manufacturing this. What can we do? We've got this additive manufacturing equipment here, and complexity is free of charge, right? So we can start adding, different profiles and everything like that into the parts. And this part ended up being about 35% less mass than the machine one and performed just as well, if not better. It was lighter, it was cheaper. We didn't sacrifice any strength or anything along those lines. And what we found out that the operators that were installing these, they actually preferred the 3D printed ones because they were smaller, which meant they could literally just put these kind of in their pocket as the thing was moving down the assembly line, unclip it from one tailgate, put it on the other. So they were smaller, they were easier to use, and they were just overall just a really good win. So why use additive manufacturing? That is the big question, right? So when we're talking production tooling, operator fatigue is a big thing, right? You're only as good as your people that are out on the shop floor, and if they're getting tired or fatigued or their hands are cramping up or anything along those lines, obviously your production's going to hurt on that. So coming up with organic designs that are specifically made for your operators and aren't just kind of machined flat pieces is going to be less fatigue on your operators and just overall, happier workplace as well. Now, the other thing is the fast turnaround on design iterations. Again, we don't know sometimes if a part's going to work, or maybe it could be made better. So we might make a part yesterday and it worked and it performed okay, but we might have somebody on the floor that say, hey, if you did this, it would make my job a lot easier. So we simply just make that design change, print it out, the operator tested it in the morning, and everything works as intended. So custom tools, that falls into that exact category as well for every operator and assembly. The low part cost for small batch tooling. Now, again, additive manufacturing is not going to displace a lot of your traditional manufacturing processes. But when it comes to low part cost and small batch tooling, it's definitely a win. There's obviously a point where your ROI tends to fall off depending on how many parts that you're producing. But definitely for low volume production, it is the way to go. The other thing too is the digital inventory reduces warehouse space. Now you might say, hey, we just kind of machine these as we need them. So we just keep a couple blocks sitting on the shelf and we machine 20 or 30 at a time. But think about it, if you didn't have to keep so many blocks of that material on your shelf, that frees up your warehouse space. Less warehouse space being taken up can be used to invest in larger equipment or more equipment. or you can just have more office space or whatever it might need to be, or maybe you just need a smaller building so you can start to save on heating, cooling, electrical bills, things along those lines. So it really comes full circle on the digital inventory and warehouse space. The other thing too, being environmentally friendly, is everybody's trying to save the planet, and we should be, right? It's our only planet. So having the less wasted materials, makes it so that we're consuming less as manufacturers, trying to save that planet. If you've ever been to like a machine shop or anything like that, there's chips flying, there's vacuums going, people are sweeping up stuff along those lines. With additive manufacturing, we don't really have that waste. We have a little bit of support structure on some parts, and a lot of times those can be designed without any support structures at all, which has almost zero waste to associate with each part. The nice thing about 3D printing or additive manufacturing as well is complexity does not cost more. What I mean by that is, again, you can come up with those organic shapes, very user friendly. It doesn't necessarily have to be everything cut on a flat plane or, very simple geometries. We can make these things very curvy and things along those natures to make them complex but more user friendly. The other thing too is limits the amount of tool makers spend making custom tools. So the last thing you want your tool maker doing is really running a bunch of prototypes when they should be, doing other things on the production floor. So if we can limit those tool makers where they're doing other things, especially if we're doing, just short run production tooling and things along those natures, this frees them up to be doing other things, whether it might be repairing assembly lines or helping out or whatever that might be. So the other thing too, here's a nice example here of what that design complexity is free using additive manufacturing. So on the left here is we have a very bulky, cumbersome alignment fixture for an assembly aid. This was very bulky. It wasn't necessarily costly to produce. It was all machined out of aluminum, but it was heavy. It was about 13 pounds when it was all said and done. So it was heavy. It was cumbersome, and operators just really didn't like the way it felt. The handles on there, just off the shelf components that were bolted onto the piece, and it just wasn't very user friendly. So they came and they asked and they said, how can we make this more user friendly, more familiar and just easier for everybody to use? So we came up with a more complex design there on the right. Now it's a assembly of a few different parts, additive manufacturing, all assembled together, but it's very, very easy to use. It's very nice on the hands. Came in about half the weight of the machined aluminum one. Save the operators that fatigue. Last thing we want those guys or gals to be doing is getting tired on the job by lifting up this aluminum fixture plate over and over and over again. You got to remember these people are lifting these things up hundreds or even maybe thousands of times a day, which is a really good workout, but not everybody wants to go to the gym every day. So what that also means too is if your workers are more comfortable and they can move faster, that also means more profit. And when you have more profit, then you have more money to be able to work with for business expansion or exploring new revenue applications or tools that you might be able to be making. That sums up the webinar for today. We do have a question section here, so if anybody has any questions on anything that was covered in this or anything that they want more information on, feel free to chime in, or please write your notes in at any time.
All right, Josh, it doesn't seem that we have any questions. Thank you for your presentation. And again, we'll send the recording out. And if there's any questions that you come up with after this presentation, please feel free to email them to sales@camlogic.com. Thank you, everyone.
Thank you, and everybody have a great day.